Although nuclear power is declining in many nations, Finland has embraced the carbon-free energy source, lobbying the European Union to label it as sustainable. 2 of the country's 4 reactors are on Olkiluoto. After a new Olkiluoto reactor is connected to the grid later this year, nuclear power will account for a major part of Finland's electricity. So why is this new nuclear plant an important source of energy for Finland, and how much power will be generated through this project? Let's find out in today's video. Hello and welcome to our channel Building the Future. In today's video, we are going to give you exclusive details about a mega nuclear project in Finland that will solve nuclear power's biggest problem. So make sure to watch the video till the end to find out more. And don't forget to subscribe to our channel for more amazing videos. Since 2005, Finland has been constructing the largest nuclear reactor in Europe alongside a facility that could solve the problem of what to do with spent nuclear fuel. When you think nuclear, the Nordic nation doesn't immediately jump to mind. But if all of its planned projects come to fruition, then, by the end of the decade, the country will be second only to France in terms of the percentage of energy drawn from nuclear systems. So, after more than 10 years of delays and cost overruns, 2022 will see the world's happiest country switch on one of the planet's most advanced reactors, potentially kickstarting a new age of nuclear power. Finland actually has a long history with nuclear power. Its first reactor came online in 1977, and by 1980, 3 more were operational, providing a third of Finland's total energy needs. When you think nuclear, the Nordic nation doesn't immediately jump to mind. But if all of its planned projects come to fruition, then, by the end of the decade, the country will be second only to France in terms of the percentage of energy drawn from nuclear systems. So, after more than 10 years of delays and cost overruns, 2022 will see the world's happiest country switch on one of the planet's most advanced reactors, potentially kickstarting a new age of nuclear power. Finland actually has a long history with nuclear power. Its first reactor came online in 1977, and by 1980, 3 more were operational, providing a third of Finland's total energy needs. While these reactors are among the most efficient in the world, running at 95% capacity factor for the past decade, and continually being uprated over their life cycle, growing demand, and the seasonal fluctuations of other renewable sources, like hydro and solar, has left the country relying on imports from Russia and Sweden to make up the balance of its energy needs. To lessen its reliance on foreign energy, and to help meet its goal of carbon neutrality by 2035, the Finnish government approved the construction of what was meant to be the world's first third-generation pressurized water reactor, called ERP, at its Olkiluoto nuclear plant. This reactor is called OL3 and building started in 2005. With an initial cost of $3.9 billion, OL3 was to nearly double the plant's existing output and provide 14% of Finland's energy needs when it became operational by 2010. But while OL3 was the first EPR to begin construction, ahead of other next-generation reactors in France, China, and the UK, complexity surrounding the design led to over a decade of delays, and in 2018, China's Taishan 1 became the first EPR reactor in the world to start operating. So, why was Olkiluoto 3 actually delayed? The 1.6 gigawatt reactor, built by the French-led Areva Siemens consortium, had originally been due to open in 2009. Using the third-generation European pressurized reactor model, which was designed to improve safety and reduce costs, it was the first nuclear power station to be procured in Europe after the 1986 Chernobyl disaster. Olkiluoto 3 was meant to be a showcase of French-German know-how, touted as offering higher power and better safety. But the project was plagued by technological problems and cost overruns. The cost ballooned from an initial estimate of €3 billion to around €11 billion, according to the 2019 World Nuclear Industry Report. Therefore, the Finnish Economy Ministry and the country's nuclear regulator said the project was beset by a string of technical and safety setbacks due to poor project management and workmanship. Moreover, the repeated delays led to bitter compensation disputes between the Finnish operator TVO and Arriva, with the latter ultimately agreeing in March 2018 to pay TVO a financial compensation of €450 million. So, despite these delays and the cost swelling to over $10 billion, Olkiluoto was granted an operating license by Finland's Radiation and Nuclear Safety Authority in 2019, and in March 2021, 116 tons of uranium began to be loaded into the reactor ahead of its final testing phase. Therefore, once it's connected to the grid and the reactor begins commercial production in late 2022, the countdown will be on until Olkiluoto begins adding to Finland's spent fuel stockpile. Now, how will it help Finland's energy needs? Over time, Olkiluoto 3 is expected to reduce the need for electricity imports from Russia, Sweden, and Norway and lead to lower prices. In addition, Olkiluoto 3 will run alongside two existing reactors, eventually becoming Europe's most powerful reactor. Once regular energy production ramps up later this year, the reactor will supply about 14% of Finland's energy at 1,650 megawatts, TVO said. Olkiluoto 3 significantly improves Finland's electricity self-sufficiency and helps in achieving carbon neutrality goals, the operator said in a statement. Apart from this, Finland's net imports of power averaged 13 terawatt-hours over the last few years, which should drop by around half by 2025, with Olkiluoto 3 in operation. So, like all energy sources, nuclear power has advantages and disadvantages, but talking about its benefits, it produces energy via nuclear fission, rather than chemical burning, which generates baseload electricity, with no output of carbon, the villainous element of global warming. So, switching from coal to natural gas is a step toward decarbonizing, since burning natural gas produces about half the carbon dioxide of burning coal. But switching from coal to nuclear power is radically decarbonizing, since nuclear power plants release greenhouse gases only from the ancillary use of fossil fuels during their construction, mining, fuel processing, maintenance, and decommissioning. About as much as solar power does, which is about 4 to 5% as much as a natural gas-fired power plant. Now, nuclear power is an incredibly clean way to produce energy, but it does create a byproduct, and it's the one problem we have yet to truly solve. After 3 to 6 years, irradiated material is no longer able to sustain a reaction as a viable fuel source, and new material must be bought in to maintain the reactor's efficiency. But while it's unable to generate electricity, spent fuel remains highly radioactive and needs to be isolated for hundreds of thousands of years to prevent it from causing harm to people or the surrounding environment. Although spent fuel can be re-enriched and re-enter the fuel cycle, the primary way in which we currently deal with radioactive waste is to simply store it in pools or sealed dry storage facilities while it slowly decays. While these methods keep spent fuel contained, it's not a viable long-term solution as the system is heavily reliant on mechanical and human intervention, and even under the strictest conditions, it can be vulnerable to acts of terrorism or natural disasters, the kind that led to the events at Fukushima in 2011. Adding to this, with an estimated 250,000 tons of high-level waste already in storage around the world, and with no long-term strategy for dealing with it, many countries have chosen to completely rule out nuclear power when it comes to meeting their growing energy needs. To solve this, since 2005, Posiva, a joint venture between Finland's two nuclear power providers, has been constructing the world's first deep geological repository for spent fuel in the billion-year-old bedrock not far from Olkiluoto 3. Funded by charges collected from consumers through electricity sales, the $1 billion project that's due to complete in 2023 will see a series of tunnels extend half a kilometer below ground, creating a permanent disposal facility for spent fuel. While burying nuclear waste might sound alarming and may cause concern to environmental groups, the process at Olkiluoto is so much more than simply burying the problem. Based on a Swedish disposal method known as KBS3, irradiated material is placed into boron steel canisters and enclosed within corrosion-resistant copper capsules before being buried in individual holes and backfilled with bentonite clay, entombing it forever. Once buried, no further mechanical or human intervention is required to contain the radioactive payload, essentially eliminating one of the biggest barriers many countries have when it comes to adopting nuclear power. In addition, with the capacity to accommodate the last 50 years' worth of Finland's accumulated spent fuel and the needs of its existing reactors until at least 2120, at which time the facility will be permanently sealed, Olkiluoto appears to provide a viable long-term solution to dealing with nuclear waste. Described as a game changer for the industry by the director of the International Atomic Energy Agency, IAEA, the lessons learned at Olkiluoto are being shared with other countries and regions with suitable geological characteristics are being considered for similar disposal sites. Having seemingly solved the biggest drawback of nuclear power and with a sixth reactor already planned to begin construction next year, Finland looks set to play a leading role in the widespread adoption of nuclear technology as the world continues to transition away from fossil fuels. We hope you enjoyed this video. We will be back soon with more amazing content, so stay tuned and don't forget to like our video and subscribe to our channel so you don't miss any of our latest updates. You can always change your mind later. Thanks for watching.